So here it is. We'll start today networking basics. There is a 4 lines. You can see what is a network, what is networking, what is internetwork, what is internetworking. Guys, network means connectivity of a devices. If there is a connection, there is a network. Okay. Simply, I have a 2 or more devices. On single device, there is no network anymore. 1 second. Uh, Okay. So guys, think like this. Here is in a network, not only computer, we can also say device. It means a computer or a laptop or maybe a printer or maybe some switch or maybe a router. All are network. All are these devices we can able to connect the network. But just for our understanding, I said a device name is A, B, and C, or maybe I will put a names A1, B1, C1. Okay. And here it is. I am connecting these devices. Okay. So interconnection of 2 or more devices called a network. Now I have created a network. To connect the devices, generally we use a device name is hub or a switch. To connect the devices in a network, we use hub or a switch. Now it is a simple network or a single segment network it is. This is one of a network it is. Okay. So this is my network. What is a network? Interconnection of 2 or more devices called a network. What is networking? For example, if you are able to communicate from a one device to another device, it means networking. What is networking? Communication between 2 or more devices is called a networking. Okay, what is meant by communication? Maybe you share some information, maybe you shared a folder data, and maybe you send a message, and maybe you send a mail. Okay, maybe you upload a document, or maybe you download a document. Okay, so maybe you use instant messaging system. You're sending a message and receiving a message. That is called a communication. To communicate, we need a connectivity and address and protocols. What are the 3 things I said? To communicate, what is the requirement? Connectivity. Then address means example a IP address. Next, protocol. These are the requirements to communicate. The first one is connectivity, the way you are connected. So this is network. What is networking? So what is a network? Interconnection of 2 or more devices is a network. The communication between 2 or more interconnected devices called a networking. This is a network. What is this internetwork? For example, you have a different networks. Okay, in a maybe in the same organization or maybe to the different organization, you have a different networks out there. and there is also a network. Okay, this is a network, and there are also network. Simple LAN network it is by using a device called a switch. I have. Okay, but you can communicate from here to here, and you can communicate from here to here, or you can communicate from here to here, or you can communicate from here to here. But you want to communicate from here to here, but there is no connectivity, right? And think like there are a separate network, separate physically and logically, different networks. There are separate network. You want to make a connection between these two different networks. We need a internet connectivity devices, internetwork connectivity devices. Okay, the connection of two or more different networks. The connection of two or more different networks, we call it as a internetwork. And the communication between two or more networks is called a internetworking. Okay, so this is now internetwork. What is a internetwork? A internetwork is a connection of two or more networks. What is internetworking? Communication between different networks. Communication between different networks. You want to communicate from these devices to this device, for example, or this device to this device, an example. Okay. So this is called a internetworking. From here, I send a message, or from here, I share a folder. From here, I can able to access it, or from here, we're able to communicate from here. Okay. That is internetworking. Internetworking is communication between different networks. Guys, understand what is network? What is networking?
Yes, sir.
So here I use a certain devices. I will explain about these devices separately, and but I given already names. So then I will explain. To create a network, what we need a hub or a switch. The router is internetworking device. Router is internetworking device. When you want to connect and make a communication between the networks, we need a router. Okay, you want to connect different networks and make a communication between the networks, we need a router. To create a simple network, either you can use hub or a switch, but you want to make a communication between different networks, we need a router. Router, the device. So network is a physical or a logical network. The physical network means connection of a devices. Logical network means depends upon the IP address configuration. Physical network means this is you're connected to the devices. It's a physical network. How you connect, that is depends upon the way it is requirement to you. Okay, it's a just connection of a devices. Based on that, you can say it is a physical network. But what is a logical network or logical topology? That is based on the configuration of IP addresses. Okay, of course, we'll see that IP address separately. How an IP address will make a logical network, that is again we'll see separately. Okay, so this is first one, network networking, internetwork, internetworking. Okay. What is physical topology? What is meant by physical topology? The way of devices you are connected. That is, you are connecting a devices, right? So here are you connected devices. Same way you can connect devices different ways. So that is called a physical topologies. Physical topology means the way are you are connecting devices. That is physical topologies. So here it is. There is a way like I have a devices. I have a devices, and these devices I connecting to a backbone wire. Okay. So for this one, I don't give any text, guys. You have to listen carefully. And if you have a doubt or you don't get a point, you can ask me again. Okay. I have a devices. These devices are connected to a backbone wire. Usually we use a coaxial cable here. In a olden days, we have a cable TV network. Now we have a dish antenna network, but olden days we have a cable TV guys there. So he has a big dishes. So he receive a satellite signal and he distribute the signal through this cables. He run the cable over the houses. Okay. From the house again, if anybody want a connection, so they will tap that connection to this main backbone cable. Okay. So same thing in the network also, in the computer communication also, they use a backbone cable and they will connect to the backbone cable. Nowadays, okay. So, so this is called a bus topology. What is meant by bus topology? Devices are connected to a backbone cable. Usually backbone cable is a coaxial cable. And devices will communicate through this backbone cable only. The devices will communicate through this backbone cable only. And it is very easy to configure and very cheaper solution. It is easy to configure and cheaper solution it is. But there is a problem. In case your backbone cable is down in a certain point, further communication will stop. You can't communicate from here to here. Okay. So what it is? Devices connected to the backbone cable and communicating through backbone cable only. It is easy to configure and cheaper the solution, cheaper cost, but okay. But problem is if your backbone cable is down in a certain point, break certain point, further communication stop, and it is very difficult to troubleshoot also because of you have to trace entire cable. You have to enter cable, you have to trace, find out where is issues occur, and you have to cut the cable and rejoin the cable with some special equipment. Okay, sometimes it is difficult to find where is the issues occur. Okay, this is bus topology. Guys, understand what is a bus topology?
Yes, sir.
So another people, because of this, if if cable is disconnecting a certain place, okay, so it problem is may occur. Like so, what the people has done, so they created another type of topologies. Okay, another way of connecting devices. What is the another type of devices? The a device is connected to another device. Another device is connected to a next device. The next device connected to another next device, and it is connected to another next device. And finally, the last device is connected to the first device. It means every system is getting a two connectivities. Okay, one is to send, one is to receive, kind of stuff. Here it is: A is connected to B, and B is connected to C is connected to D is connected to E, and E is connected to A. The communication is happen either clockwise or anti-clockwise. We need a configuration like that. So if you want to communicate from A to D, and packet is has to go for A to B, B to C, C to D. Now packet is received, and D is replying to A. So D to E and D to, like this. Means communication is always either clockwise direction or anti-clockwise direction only. Okay. So it's from here to here. See how much distance it is there. From here to here, very lesser the distance. Okay. It's not having any backbone wires, but it depends upon the next device. Of course, it has some protocols and some algorithms used to communicate between the devices. For example, A to D communication. C is down. A send a packet to B, B send a packet. So where it can send, it is down. So we cannot able to communicate. But D can communicate it to A. Okay. So that is the this particular topology. Even a wire is broken. So no further communication. One side of communication is not happening. So it is also difficult to trace where is exactly problem occur. If system is down, device is down, no problem. So we can understand device is down. But
Sir,
more devices are, it's very difficult again. Yeah,
sir,
tell me. Yeah.
sir, can you please explain the point just prior to this point which you explained right now?
Bus topology or this topology?
No, this regarding this ring topology, the point which you explained prior to this.
No, no, okay, I will explain. So A want to communicate it to D. It has to send a packet either clockwise or anti-clockwise. Suppose it is clockwise. A to B, B to C, C to D. Okay. Again, D want to send a packet to A. It is simple, one step only. D to E, E to A only. Okay. In case C device is down, what happened to the communication? A to B, and there is no C, so it is down. So we cannot able to communicate. But D can communicate to A because there is a path is there, but this path is broken. Even the cable is broken, so still you can't able to communicate. Okay, that's the
Yes.
point I told. And it is, of course, based on that algorithms, based on the protocols, we can easily create this one. But there is a few problems will occur. Here it is. If you add one more device, for example, F device is added. Okay, one more device is added. Again, you have to change complete path. You have to change complete path. Again, you have to reconfigure entirely how the communication has to be done. You have to reconfigure entirely. Think like this, you have a 50 systems, you have to configure all 50 systems. It's become very difficult. And difficult to troubleshoot is also there. Okay, this is the ring topology. And of course, there is a problem that is a uh, what we can say clockwise direction problem is there. No? That is we can able to solve by adding secondary path. Means each device is connecting with a another additional connectivity. Now one connectivity is like a clockwise direction communication. Okay. In another connectivity is anti-clockwise direction. Okay. So it is become make a communication easy, even though a device is down or a cable is disconnected, still we can able to communicate one way or another way, we can able to connect. That is called a double ring topology. That is called a double ring topology. Still the complexity is there, difficulty troubleshooting is like that. So bus topology and ring topology.
As we see,
And which one is? We don't use both the things. Okay. Now, this topology is connecting every device to every other devices. In bus topology, if one wire is broken like this, so further communication is stopped. Here it is one of the device is down or maybe a wire is broken, the further communication is stopped. But here it is every device is connected to all other devices. Anybody guess what topology it is?
star, star topology.
Mesh.
Mesh topology. Okay. For easy writing purpose, what we do, we'll put a star and we'll configure. But this is actually mesh topology. Okay. What is a mesh topology? Every device is connected to all other devices. A is connected to B, A is connected to C, A is connected to D, A is connected to E, and B is connected to A, C, D, E. E is connected to A, B, C, D. Every device is connected to all other devices. Okay. In this one, if you one of the device is down, but remaining devices will communicate each other. A wire is broken, but only A to C communication is stopped, but remaining communication is going on. Okay. So this type of networks, we don't use it generally in our local LAN communication. So why? Because of it's a lot of wiring, more number of devices, like for 2, 4 systems are there, no problem. You have 10 systems, 50 systems. The wiring is completely your house, your means your office is become with all wires only. Okay. And the device must have more NICs to connect. More connectivity points are required for the device. That is difficult, right? But it is redundant. Redundant means even though a cable is broken, a device is down in the network, still we can able to communicate. Other than that, one path may be broken, maybe one device is broken, but remaining communication is still going on. Okay, it does not depends upon any other devices. It's only on the cable connectivity. Problem is, it is complex. It is complex. It's designing is very complex. You have to connect one device to another device. Lot of cabling connectivity is there, and very difficult to troubleshoot. You don't know where is this cable, which cable is down, and exactly where it is happened. Like that, it is very difficult to troubleshoot and complex to create the network. It's not a simple one, but highly redundant. And where we use these mesh topologies, the mesh topologies are used in a core networking places. It means ISP side, data centers. We discussed the data center, right? So it contains multiple servers, right? So between the servers, we need a redundant type of network. So between the servers, you want to create a redundant type of network, means multiple paths of cables. One cable down, no problem. Other cable will with we can able to communicate. One server is down, no problem. Other server will communicate. So where we need this type of redundancy, there we use this mesh topologies. SAN type of things. In the storages, there is centralized storages. SAN storage is there. Okay, storage area networks are there. What is this SAN storage? Here also redundancy. There is a storage servers, storage devices are there. And there is a storage related switches, fiber optical switches, they use it. Not a cable, so fiber optical cables, they are using it. Okay, so how they will create like a one server is connected to multiple switches. Okay, and the storage device is also connected to multiple switches like this. It's a kind of full mesh topology. They will create it. So it is a redundant, means if this switch is down, no problem, there is a path to communicate. If this server is down, no problem, there is a path to communicate. Okay. So like that, they'll create a mesh topologies. For mesh and full mesh topologies, they use it. Full mesh topology means combination of star and mesh topology called a full mesh topology. Again, what is a mesh topology? Devices are connecting each other. Every device is connected to all other devices. Okay, it is complex to create, difficult to troubleshoot, but it is a redundance. Means one of the device is down or one of the cable is down. For all other communication is still going on. That is a mesh topology. Now we'll go to this topology. This is devices are connecting to a centralized device. The device is connected to a centralized device. The centralized device can be hub, can be a switch. Centralized device can be a hub, can be a switch. So in bus topology, ring topology, mesh topologies, for connecting, we are not using any separate devices. We are used only cables. But in this topology, we are using a centralized device. So all these devices should communicating through this centralized device only. A want to communicate it to B, the packet has to send to the switch or a hub device, and that will be sent it to another device. Okay. For example, D want to communicate it to F, so it has to go through this switch on. It is very easy to create, and the additional cost is there. The cost is on the hub and switches. If one of the device is down, only this particular device cannot be communicated. If wire is broken, so only this specific path of communication only stopped. Remaining communication is going on. Okay, a specific device or a specific path is down, only that communication will stop. Okay, so this is, and if in case the centralized device is down, total communication is stopped. So again, what is this type of topology? Any guesses?
Star.
Very good. Is a star topology. Okay. So devices are connected to a centralized device. What is a star topologies? Devices connected to a centralized device. And devices are communicating through the centralized device. The centralized device can be hub or it can be a switch. Okay. And it is very easy to configure and easy to troubleshoot. Easy to configure and easy to troubleshoot. That is a star topology. And it is scalable. One more important is it is scalable. What is a scalable? Ability to increase. Ability to increase. That is a scalability. So I have a 6 systems, 10 systems are there in my network. Now I got more systems. And all things should be in the same network, same network. So what I have to do? So see it is. So if you see in a offices or in a companies, you may see there is a lot of systems are there. Okay. Lot of systems are connected, all are communicating. Okay. How it is possible? Because of this hub and switches having limited ports means like a if you take a switch that is 24 ports switch only. If you take hub maximum 18 or 6 port switches only. Hub switches are so hubs is a 8 ports hub 4 port hub 16 port hub is there. But in switches 24 port switches 40 to 48 port switches also there, but still you have 100 computers. Okay, so we can able to connect these things together. Okay, you can connect these two things together and make it as a single segment. Earlier it is earlier it is this is a one segment, this is another segment, this is one network, this is another network. Okay, now it is both are same segment, it means same network only, not a different network. Okay, so we can connect these things. So that is called a scalability. This type of topology we call it as a extended star topologies. Extended star topologies. This is a star topology. This is a star topology. This is a star topology. But we combine this, we connecting this switch to this switch, and it is become a extended star topology. It is become bigger the network. So larger the devices, multiple devices, we can able to connect it in a single segment or single network. Okay, that is the advantage of star topology. And we are all using this star topology only in your organizations, internet centers, in your home. So we are all using star topology. Of course, in your home, maybe it is a wireless network, but whatsoever it is, we are connecting to a single point only. Okay, so that is star topology. Guys, understand what is a star topology? Simple to create.
So the hub and switch in case of using the internet at home, the hub and switch is the Wi-Fi router.
If hub and switches, you are connected internet to hub or switch.
That would be the Wi-Fi router, right?
Yeah, this is like a internet connection only. Just I have a router, internet device is there now, and I take a cable and connect it to here. Then it is internet is coming to all these big things.
Okay. Thank you.
And what is a star topology? The devices are connected to a centralized device and devices communicating through the centralized device. It is very easy to configure and easy to troubleshoot. How easy to troubleshoot? For example, if this cable is down, so there is an indication, a hub, so there is a indication, LED indication will shows disconnection, means it's not glow. So we can understand, oh, it's a cable problem or system problem like that. We can understand. Even a hub is down or switch is down. Maybe the segment, entire segment, communication stop. This entire segment, communication stop. Okay. So based on that, we can easily understand how it is communicate. Okay. It's easy to configure, easy to troubleshoot, and devices are connected to centralized devices and communicating through centralized device. And it is scalable. We can extend our network and create a bigger size network with a lot of devices inside. Okay. So multiple number of devices we can able to connect in a single network or a single segment. Someone send a message. That is again different part. vSAN and chef storage, that is different part. I said only SAN. vSAN is again virtual SAN. That concept is little different.
But sir, it is almost the same thing now.
Yeah, almost the
Like
same.
the storage has been centralized. Like the main
Uh,
core
yeah,
concept has
yeah,
been
it's
same, na?
centralized solution only. It is
Yeah.
centralized solution only.
Yeah.
Yeah. vSAN is also centralized storage, but already have a SAN, the virtual type of connectivity. So virtualizing software defined SAN network is there. That is vSAN. Yeah, where we have things, guys. Again, once again, so bus topology, ring topology, mesh topology, star topologies. So these are the main topologies. Hybrid means combination of two topologies, two or more topologies called a hybrid topologies. For example, the devices are connecting one to another one. That is a point-to-point topologies. But it is a mesh topology. Or combination of mesh and star topology. Combination of mesh and star topology is called a full mesh topology. That is also hybrid topology. Tree topologies also comes under hybrid topologies. There is no tree topologies, but some people are asking me what is a tree topology, and they make that is a more important thing. So I made it as one topology. Okay. As a per Cisco, there is no tree part. As I know, I have read to the lot of textbooks. What is a point to point, guys? If we connect two devices, either it is two computers, or maybe a computer to a hub, or a device to a switch, okay, or switch to switch, or hub to hub, switch to router. So that is point to point. But another way of telling the point to point topology is, for example, this is my corporate office, and there is a router, the corporate office, and I have a branch office, only one branch office. From here to here, I want to send and receive data. So what I will do, through the WAN, I will connect this. So one point to another point, I have connected. This is my New York corporate office. This is India main office. Okay, in India office. So there is a infrastructure is there. Here it is infrastructure is there. They should communicate each other. So then I will connect my corporate office to my branch office. That is point to point. Point to multi-point. Same concept. I have a main corporate office and I have a lot of branch offices in different geographical locations. So then I will connect from one to multiple things like this. This is main New York office and this is Hyderabad office. This is New Delhi office, or maybe this is in Melbourne or Sydney office. Okay. So then it is a point to multi-point topologies. Another one is a tree topology. Tree topology, if you see, there is a backbone wire, just like your bus topology. There is a backbone wire. Okay, different departments, different networks are connecting through this backbone wire. If you see, Here it is one small tree topology that is connected to your backbone wire. There is a server is connected to backbone wire. Just like how tree is there, there is a tree and lot of branches. Think is a stem is as a backbone cable, and to the stem you are connecting the branches. Each branch is a kind of network. A branch contains another branch, sub branch it is. Okay, just like if it is a formation, so that is we call it as a tree topology. Okay, guys, understand bus topology, star topology, ring topology, and mesh topology. It is. Bus topology easy to connect, okay, and cheaper because we take one backbone cable, we are connecting devices to the backbone cable. In ring topology, we are connecting one device to another device to another device, another device, another. Finally, last device is connected to first device, is like a loop, closed loop
Sir,
circuit. Yeah, tell me.
sir, in the point to multi-point topology, they are not, if the connection is too far away, like between countries, so it won't be physically connected, right? There would be
Yeah, they
wireless
won't be
connection.
physically connected. There is no physical direct connection is there. So there is a logical connection based on the service providers. ISPs are there. For example, this is New York office and this is Hyderabad. So in New York office, in generally it is physical. It is look like this one, but what they how they will connect? They'll connect New York. Their service provider is their network service, internet service provider. So there is a connected to this one, and here is another service provider in India. So they will connect each other in a some private channel. Okay. They will connect,
The service
but directly we
providers.
are not. Yeah, service provider like Sahara, HCL, Jio, Reliance, Tata. Okay,
Okay.
I think Tata is also there, but Reliance is there from so many years.
Yes, sir.
In almost like 2000. That time only that uh, we
So
have
they
a
are connected.
government. Uh,
They are connected to ISPs servers through
they
wires,
have a setup to connect through the fiber optical cables under the oceans.
fiber optic cable, yeah, yeah. And the ISP servers would be connected through a wireless connection, right? Between each other.
We are connecting to ISPs, nearest ISP. These
Yeah, yeah.
ISPs are connected under ocean fiber optical cables.
No, no, the two different ISP servers between the two
Mm.
countries, they would be connected through a wireless connection, right?
Not wireless.
They also would be connected through fiber opticals.
Yeah, they're also connected. These to this fiber optical connection is there.
Okay. Sure. Thank you, sir.
From here to here, maybe fiber optical, maybe normal LAN cable, depends, or maybe telephone cables, depends upon the network. Now we are getting fiber optical to home, so that's we are getting. But in ISPs to ISPs, there are direct fiber optical cables, under ocean fiber optical cables, under land also.
Okay, sir. Thank you.
BSNL, all these things will do like that. Okay. So once again, very good. That's a good question actually. That gives clarify to lot of people. Okay, so guys, we are all getting internet through the fiber optic cables, that is under ocean fiber optic cable. We are able to access YouTube. Maybe YouTube is not in India, maybe it is there in US, right? A lot of other country sites, websites we are accessing through this under ocean fiber optic cable, not through the satellites. Okay, not through the some wireless kind of stuff. Okay, that's a good point. Okay. So ring topology, mesh topology is every device is connected to all other devices. Star topology, every device is connected to a centralized device and communicating through centralized device. Those are the important points and the differences. And what topology we are using? Star topology we are using. We are not using bus, we are not using mesh, we are not using ring. We are using star topology. Okay. So take a break, guys. So then we will discuss about a types of network. What is LAN, CAN, MAN kind of stuff. What is intra-network? What is internetwork? Extra network, that is okay, no problem. Okay, small topic we will discuss about a LAN, CAN kind of stuff. So take a small break. Okay, so 10 minutes, come back at 11:30. Because it's 11:20.